Hey, good morning. I'm excited to talk a bit about where we see the space going, where we see the world going, and what's going to be the future of enabling the next generation of advanced models and AI systems. Before that, I want to talk a little bit about why this event is significant to us and why the community here in Europe is significant to us. We started doing this event series 7 years ago. The first one was in 2018. And the North Star, or the through line, through our whole history of doing this event has been AI impact. You know, it's very easy to get lost in all the noise and the hype and the buzz around AI, especially these days when sort of everyone is calling everything artificial intelligence. And we're really proud of the work we've done to help our customers, particularly our customers in Europe, drive significant and in some cases really literally world-changing impact from data science and AI. To give you a couple of examples of this, UBS has, among other things, built their modern next-generation risk modeling platform on top of Domino, helping to secure global financial markets. You're going to hear a lot more about some amazing things that UBS has done later today. BNP Paribas Cardiff has, among other things, I mean, they've got hundreds of use cases, but among other things, they have modernized and automated claims processing, which is useful both for, of course, improving internal efficiency, but more importantly for materially improving customer experiences. In some cases, they've seen time to process claims go from 7 days down to 1 day. And what I believe is currently the largest pharmaceutical company in Europe by market cap has, among other things, used our platform to build models that automate lab environments to help design new potential drug compounds to accelerate drug discovery and bring innovative medicine to market. So, you know, this is the kind of thing that we get excited about when we talk about the potential of AI to change the world, not just all the chatbots running around. The other thing that's kind of particularly significant and important to us about being over here is the community in Europe, and what I've always felt was a really strong values alignment between Domino and our product philosophy, the thing, kind of some of the core ideas we have about how to build a platform in this space, and the values for organizations over here. So, you know, we started working with customers in Europe almost a decade ago, 2016, and one of the things that I think has made this environment a really great place for us, and why we always like coming over here, why we built the team over here, is a lot of the core principles that have guided our approach along the way seem to be very natural and resonant with how organizations over here are thinking about how they want to evolve their data science and AI strategies. And we saw some of this in the recap Thomas just shared, but let me highlight a couple other points, or maybe underscore some of those points. Europe, I think, has always led the way, especially relative to North America, when it comes to thinking about the importance of security and privacy. And as an example, you know, we are one of the only platforms in the space now that has prioritized and made a first-class offering for on-premise data science platforms. And beyond that, we're the only one I know of that has a first-class hybrid and multi-cloud solution. And that's something we've seen become increasingly important as European organizations in particular really think about data privacy and security. Thomas mentioned the importance of governance, and we see Europe really leading the way on governance. I think you've been much farther ahead of the United States in terms of regulation around these areas. And that was one of the reasons that we built a whole new product capability last year focused on the application and definition of governance policies. We're going to talk a little bit more about that later. But even going back farther in our history, we've, from the very beginning, prioritized things critical to governance, like reproducibility and auditability. And finally, Thomas mentioned this as well, you know, we see a lot more Europe seems to embrace the ecosystem of all the open source solutions and all the providers building innovation on their own, rather than what we see a bit more of in the US, which is sort of more of a focus on proprietary solutions and kind of walled garden solutions. And that's core to our original product philosophy. We've always invested in building extensibility and openness and flexibility in the platform so that our customers can use the latest and greatest techniques and tools and technologies from the ecosystem. That's been core to everything we've done from the beginning. We've done a lot to go even farther than that, and we're really proud of the recognition and the partnership we've gotten from some of the leading providers in the ecosystem. NVIDIA and Snowflake, for example, have partnerships with us. They're actually also strategic investors in Domino. And late last year, we announced a new material partnership and strategic investment from another critical player in the space, one of the leaders when it comes to data storage solutions, NetApp. You're going to hear more about what we've built and where we're going with a deep technology integration with their technology, and we're going to hear from folks from NetApp later today as well. So all that is to say, we've always felt like Europe was sort of a kindred spirit in how we've always thought about the principles that are guiding what we're building. So thank you for the collaboration, the partnership, and the sort of the embrace from the community over here. Okay, what I want to talk about. Oh, sorry. One last thing I'll say about this is some of these kind of core ideas: security, privacy, ecosystem flexibility, openness, governance. They are really core to our vision for the platform and what we're building and our North Star. And the idea we've always had that we're sort of doubling and tripling down on now as we've moved from data science to predictive ML, now to generative and agentic AI, is the idea that organizations need a unified place to complete sort of the full model development lifecycle, going from development through experimentation, through deployment and monitoring. And the thing that has to underpin that life cycle is a core set of capabilities that really align to these sort of organizational requirements that enterprises have for doing this work at scale. That's things like reproducibility, auditability, flexibility to use the latest and greatest technologies from the ecosystem, reusability so your organization can scale and not reinvent the wheel. And we believe that that same set of capabilities applies whether you're doing traditional data science, whether you're doing predictive ML, and now whether you're doing Gen AI or agentic AI. So that's our guiding vision for the platform and what we're building. And that's kind of my segue to what I want to talk about for most of the time here, which is a term you're going to start hearing more and more of, and you've probably already heard a lot about it. And it's this concept of a modern AI factory. This is something that enterprises will need to build the capability around themselves as they scale their AI efforts. And it's a term that's going to, for a little while, be thrown around, and different people are going to mean different things by it. So I want to start by defining kind of what I mean by the AI factory. I'm going to use a starting point, which is what NVIDIA's CEO described at GTC back in March. Jensen said, AI factories have only one job: to generate tokens that then get reconstituted into music and words and videos or research or chemicals or proteins. So this is a starting point for a definition. NVIDIA's definition of the AI factory is basically a thing that takes dollars and electricity and turns them into tokens. And I think that's a fine starting point, but there are a couple ways I think this definition is incomplete. In particular, I think it's a definition sort of narrowly for companies that are what I'm going to call AI consumers. If your relationship with AI is just, hey, we use these LLMs and that's all we do, then this is a fine definition. But leading enterprises, I think like a lot of folks in this room, are not just consumers of AI, they're builders of AI. And if you're a builder of AI, then you're not just generating tokens, but you're also generating, in some cases, your own foundation models, or maybe you're fine-tuning foundation models. You're certainly building a lot of your own, what I'm going to call Gen AI systems. It's like a RAG architecture around an LLM. And you've got a foundation that's going to continue, I think, to be sort of the workhorse of AI, which is traditional predictive machine learning. And so you're going to be building a lot of predictive models that have nothing to do with Gen AI. And so if you're an AI builder, I want to posit the AI factory for you is really about how do you take your set of ideas and use cases and, as rapidly as possible, build models and AI systems that generate as much business impact as possible. So your output from the AI factory is not the tokens, it is these models and AI systems that are driving business impact. And I want to posit this definition because I think it leads to a sort of a useful set of questions you can go back to your organization and ask. Namely, if this is our definition of a factory, what are the most important levers we can pull to increase throughput? So the name of the game in the factory is how do we increase the rate at which we're able to build and deliver these systems and models? And there are two key levers to think about pulling. One is the latency, like how do you reduce the time to value from the start of a project to the delivery of it, time from inception of a model to production of the model. And the second lever is the bandwidth. It's how many of these can we take on and deliver in parallel. And if you can ask those two questions, you can start to figure out what are the most direct, high-impact paths to optimize the throughput of your AI factory. Something that's pretty interesting is when we talk to customers about the biggest bottlenecks to the throughput of their factories they're building, the themes we hear over and over again are basically the same things we've been hearing for the last 10 years. So even as we've moved from data science to predictive ML to now Gen AI, the core challenges enterprises have in scaling this kind of work are very, very similar, even though the particular details of the technologies have changed. And the three biggest challenges we hear over and over again, first one is, it is still really, really hard to orchestrate and coordinate all the infrastructure and the technology required to build these kinds of systems. A lot of expert modelers and data scientists are not infrastructure engineers, and as the technologies used have gotten more complicated, the infrastructure requirements have gotten more complex, this challenge has only gotten worse, not better. The second challenge we hear over and over again is the reinventing the wheel problem. As organizations scale, there's this thought that, hey, we've had success with a couple of models, now we're going to go scale that out. We've got lots of use cases to go tackle. Let's get more people doing this work. Let's hire more data scientists. Then everything's going to get much better, right? We'll have more people. Well, unfortunately, what can happen is, as you add more people, you end up with a lot of folks bumping into each other and making a big mess. And you get duplicated versions of the same model, and you get people reinventing the wheel and starting from scratch instead of building on past work. And suddenly now you've got 20 different versions of a forecasting model that should have all been the same thing. And that creates organizational debt and tech debt and AI system debt. The third challenge is what happens after you build the model, and what are the steps that have to get taken to put this thing into production in a safe way, consistent with your organization's security policies, governance policies, relevant regulatory constraints, and that whole set of work. And we hear things like the process of going through model validation, model governance and review can take twice as long as the time to actually build the model itself. And that's a real problem when you're doing work that is going to drive a high degree of business impact. To have that kind of delay is it's a tragic opportunity lost. And again, as the new techniques we've moved into now with Gen AI models and LLMs, as those types of use cases and models have gotten more opaque and their range of behaviors has gotten even more unpredictable, the governance challenge and the sort of oversight challenge has gotten harder, not easier. So as we've increased complexity of the modeling methodologies, these problems have gotten worse. So what I want to talk about next is kind of it's our vision for how the modern AI factory addresses these problems. And I want to convey this vision through sort of an extended visual metaphor. I'm going to talk about three capabilities we think all enterprises are going to need to build their modern AI factory. The first one is essentially like a laboratory environment. I'm using this word factory, and factory implies a regimented, homogenized way of doing things. And part of delivering AI is like that. Part of it is highly controlled and regimented. But a lot of early work in AI is the opposite. It is more like being in a scientific laboratory environment. And what's really important is creating a high degree of agility for folks to rapidly experiment and test new ideas. So often when you're starting an AI or data science project, you don't even know if your original idea is going to work. You don't know the best way to approach it. And so enterprises need to have the space for data scientists to rapidly experiment to drive innovation. Now, the trick after that is once you've figured out the thing that works, that's when you need to be able to move it into production in a streamlined but also a safe and controlled way. And this idea of sort of standardizing how things get moved into production, there are really a couple different flavors of that. I mean, the first way is once we have a model we want to put into production, what is our standard way of doing that? But the other flavor of this that's really important to keep in mind is once you have, coming out of that lab environment, once you have a methodology you know is going to work or a pattern you know is going to work, how can you templatize that so that you can stamp out new versions of that really quickly? So, let's say we've got our best methodology for how we want to do some kind of forecasting. How do we turn that into a template so that we can go stamp that out in different countries we operate in, for example? So the learning coming out of the lab environment should be able to be turned into reusable, repeatable, standardized ways of more rapidly pushing similar flavors of models into production going forward. And then the sort of the third facet of this factory is how do you have control over this whole process, this whole life cycle? And to use the metaphor of like a physical factory, imagine the quality control checkpoints along the assembly line. Imagine how are we ensuring at each stage of the process that what we've done is up to our standards, and how do we have visibility? Imagine like the foreman in the factory floor overseeing how is this all operating, is everything safe, is everything up to our standards, how are we continuously improving? So these are the three kind of abstract conceptual components of the modern factory. The rapid experimentation environment that creates a lot of agility for innovation, being able to take that and seamlessly transition it to a more standardized ways to increase the throughput of work to production, and then overlooking or overarching all of that, a way to put in place controls and oversight. And obviously this looks very clean and neat and tidy. Probably not surprising, when we start working with most organizations we partner with, when we go into that environment, the state of the world is much more of a chaotic mess. At each different stage of the life cycle, there are duplicative or redundant tools, different ways of doing the same thing depending on the stage of the life cycle you're working in. You've got folks around the organization that are directly connecting to data, using their own tools. I spoke to a chief architect at one of the top 10 global pharmaceutical companies, and he told me the story of how he had been walking the halls. He saw a data scientist who had a server under their desk with some tape around the power cord that said, "Do not unplug." And he said, "Why shouldn't I unplug this?" And the person said, "Well, there are production models running on this. So if you turn it off, really bad things will happen." That's an example of what happens when you have more of kind of a Wild West or a chaotic way of organizing this work instead of a more modern, orchestrated factory environment. Obviously, solving this problem and setting up a modern AI factory requires a lot of work across organizational design, across internal processes, but technology plays a big role in the solution of this, and that's the role that we play at Domino. Our insight and our approach to helping our customers solve this problem is to give them a layer of abstraction or layer of indirection that makes it easy to centralize access to all these disparate materials, the tools, the data, now the LLMs, the compute resources you need. And it turns out that layer of indirection or that orchestration layer really nicely solves all the problems I laid out a minute ago. One, it provides a easy, consistent, standardized interface to access and orchestrate all the infrastructure you need. So your data scientists don't have to be DevOps, infrastructure, engineering experts. They can, through a sort of templatized interface, get access to all the compute resources and software they need. At the same time, it creates a place where you can define templates and standard ways of working so that new use cases and new models and projects can be stamped out much more streamlined. And finally, it provides a choke point to implement security and safety controls so you can ensure, hey, all the work is automatically being tracked. We have security and we have access controls in place. We can enforce our policies over how all this work is done. So this is the approach we've taken. And we think it's incredibly powerful, and it's sort of the technology breakthrough or insight that's necessary to unlock this modern AI factory. I know that's a little abstract. I want to give you a more concrete version of some of what we've been building to enable this kind of functionality. I'm gonna highlight a few areas of some recent product capabilities we built that I'm really excited about. Some of these we built earlier this year. Some of these are just kind of fresh out of our engineering kitchen in our 6.1 release, which just shipped yesterday, and so customers will be getting that soon. I'm gonna just highlight a couple tidbits around these three different areas of the factory, again, just to kind of illustrate what we mean by this more concretely. So when we talk about creating agility for data scientists to more rapidly experiment, you know, we spent a long time thinking about how to create the ideal experience for data scientists. And we know that a data scientist's job is really, really hard. It involves a lot of complicated tools. It involves a rapidly changing ecosystem of software and data types. And so creating the sort of flexibility and power for data scientists is paramount. We've done a couple things to make that easier. I'm going to talk about each of these. The first thing we've opened up a whole new way for data scientists to use their preferred IDEs with flexible compute, scalable compute backends, and flexibility and things like automatic reproducibility, the power of our backend servers. But we've opened that up to connect to Domino's backend compute infrastructure through secured SSH, running your own preferred IDEs on your desktop. We're seeing a lot more adoption now in the community of, say, VS Code as opposed to Jupyter, which was much more common a few years ago. But with, you know, we're sort of seeing the tool preferences shift in the market, and this is a really great way now to use your preferred IDEs with your preferred local configuration, but with powerful scalable compute and reproducibility automatically built into the back end. The other powerful thing about this is it opens up a whole new world of let's call them more specialized development tools that maybe can't run in a web-based interface. You can now run those in your local development environment and still benefit from the flexible, scalable compute and reproducibility of our backend. The other thing we've done more on the data side is through our partnership with NetApp, we have deeply integrated their ONTAP storage technology. This is doing a couple things, and there's a lot more that's going to come on this in the future. Out of the box today in Domino now, we will do near instantaneous data snapshotting and using NetApp's technology to do smart deduplication. So large, you know, even sort of terabyte size data snapshots will be made instantly, and also with very, very little storage overhead. So the great thing about this is, as you're working, especially in use cases where reproducibility and lineage and data versioning is critical in regulated environments, Domino will do all that for you automatically without time or cost overhead of all the data snapshotting. Next, I want to talk about what we've done to make it easier and more streamlined to move work into production. This is another interesting case where, as we're seeing a shift from more traditional predictive ML to more generative and agentic AI, we're seeing some of the patterns and the modalities of deploying work change. So, you know, it used to be that deployment or production really meant primarily a inference API for a real-time model. Well, with Gen AI and with agentic AI, what we're seeing is that the more common modality is more of a user-facing application, a chatbot or an interface that some human interacts with for a human-in-the-loop mode. And so what we've done is we've completely rebuilt, sort of overhauled a capability in our platform for easily publishing what we call apps. And apps are interactive user experiences, wrap models. The way we've approached this, being true to our core philosophy of embracing the ecosystem and giving our customers flexibility, is we let you use your preferred app development framework, whether that's Shiny or Streamlit or Dash or Flask or what have you. And what we're doing is we are automating all the DevOps around that. So scalability, uptime, security, and you have a very easy way to put these user interfaces and agentic or generative AI systems in the hands of your internal users and customers inside your organization without any of the DevOps hassle, without needing to be blocked on IT or anything like that. We've overhauled the backend for how we do this. This is a lot more flexible going forward. For existing Domino customers, you will also be happy to know a little bit of inside baseball here. We've done a bunch of improvements to let you use the most powerful, flexible features in these app frameworks. Things like deep linking, query parameters. We now let you customize your own URLs. So this is going to be great, and we're already seeing customers deliver a bunch of really amazing stuff with this new deployment or production modality. The third area I'll talk about is what we've been doing to enable more control and oversight. I'll talk about a couple of things here. I'm going to talk about what we've been doing for governance in terms of putting in place sort of your own internal policies, policy management that can be used for things like model validation, model risk management. It's very flexible. We'll talk about that. But then also governance from a perspective of cost, which is an increasing concern for customers as the infrastructure complexity of these new types of models grows rapidly. So first, let me talk about governance. We launched a new product late last year that we called Governance, and it is all about letting our customers define their own policies and having the completion of those policies be tightly integrated with the model development experience. So governance doesn't happen after the fact as a tacked-on process. It happens coincident with model development itself, accelerating time to value. The way this works is you can define your own policies. These can be whatever you want. You can have your implementation of the AI Act. You can have your implementation of a model risk management policy. And Domino then surfaces, in the course of the development of the modeling project, all the evidence that's required and all the governance input needed to be specified to adhere to that policy. So as the data scientists are working, they're completing that policy, they're filling these things out, and it's one place where your model validators and your data scientists and modelers can collaborate in a shared space. Now, what we've done as of this week is we've expanded this with a couple of things that are taking this to the next level and that we're really excited about. The first thing we've done is we have built in automation on top of this. So now you can define in your governance policies automated checks well, first let's talk about sort of automated evidence production. You can define automations that will compute or calculate certain things you want in all of your modeling projects. So for example, bias analyses, explainability analyses, ethical analyses of LLMs you might want to use. Instead of having every project reinvent the wheel for how that's done and do manual work to do that, you can define that once as part of a policy, and we will automatically compute it for you as models go through the development process. The second thing we've done is we've built ways to define automatic threshold checks based on metrics in your modeling project. So if part of your policy, for example, is every model needs to have a certain accuracy score, if it's below that, it's got to have some extra manual review, you can program that in and we'll do that automatic calculation for you. So again, we think this is going to streamline the time it takes to get models through governance and validation processes and also standardize how it's done across the organization so there's not reinventing the wheel. We've also built on top of our governance product the ability to manage findings and issue approvals conditional on certain findings being remediated within a certain time frame. We know this is really important for organizations that have to adhere to certain regulations around these kinds of things. And finally, we've built in formal technical gates in the platform so that you can now say, we want to enforce that there's no way a certain model can be deployed until it has had certain sign-off from certain reviewers or validators. So, the way where we're going with all this is that governance, that control and oversight layer I talked about in the factory, we believe has to be deeply integrated with the rest of the model development lifecycle. And we think that the best way to do that is to have all this work happen in one place. The last thing I want to talk about from a control and oversight perspective is cost. The generative AI uses a lot more GPUs. The data volumes for this kind of stuff, these kind of models, is a lot higher. And we hear from all of our customers that infrastructure costs are rising, and it's something they're all trying to get their arms around. So what we've done is we built a FinOps capability, and we're the only ones that are able to, the only platform that's able to do this as far as I know. The first thing we'll do is we will provide you with granular attribution of where all your infrastructure costs are coming from in terms of the actual modeling projects, the actual data science teams, the actual models themselves. So not what type of EC2 instance cost me how much money, but like this model, how much money did it cost me? How much did it cost to train this particular model? How much did this individual data scientist spend over the course of a month? And we've gone beyond that as well. Not only can you see it, but you can actually put limits and quotas and budgets in place. So you have visibility and you have control. And again, we think that as more organizations get a little more rigorous in thinking about the ROI of their data science and AI projects, this deep connection to the infrastructure cost is going to be increasingly critical. So I hope that makes it a little more concrete, kind of what we mean by these three areas of the AI factory: how to enable agility for data scientists to experiment rapidly, how to have a more standardized way to move work into production, and how to have control and oversight around all that. The last thing I want to talk about is a bit more forward-looking, and it's something we're really excited about in terms of where we see the future of this factory going, and what we see as the future of how data scientists are going to work in a year, 2 years. Maybe it'll happen that fast, but certainly over the coming years. There's a thing that's happened in the last year or so, 2 years, that has enabled a step change in the experience we think data scientists are going to have. And we've been hearing a lot of news and buzz and stories about this in the world, but they've mostly been focused on software engineers, right? So I'm sure everyone here has heard about vibe coding. This is all the rage. Everyone's talking about vibe coding because these chat bots and LLMs have enabled code generation, and it works pretty well for a certain set of use cases. And so software engineers are really excited about this, and there are coding assistants and all the popular IDEs. And everyone's talking about how it's going to change the software engineering industry. Well, for data scientists, it's a little bit different because writing code is part of what a data scientist does. Writing code is part of modeling, but it is by no means all of it. In fact, with a model, especially in a complex or regulated environment, the final output is important, but what's just as important is how you got there. What was the data you used? What were the set of ideas you tested? What was your thought process for why you tried certain things but didn't try certain other things? How did you review the data to ensure that it was appropriate to use and legal to use? Things like that. And so with data science work, what's just as critical as the code you write is having the record and all the metadata and the history of your research process, your thought process, how you got to the final output. And we are really excited to embrace that idea because we think with the foundation we've got and the AI Factory technology platform we've already built, we have a lot of that information. We have this foundation that is tracking the history of what you've done, is tracking the records, the experiments you've tried, is making your data reproducible and giving you data lineage. And so what we've done is we've combined this sort of new generation of coding assistants with this powerful foundation we've got. And what we've done, and what I want to show you a preview of, is what we're calling vibe modeling. We think this is going to be the future of how data scientists are going to work. We're really excited to show you more about it. Basically, what we've done is we've put an MCP compatibility layer on top of our existing platform APIs. So not only now can you use a coding assistant to generate some code, write some Python, that's fine. You can also tell your coding assistants how to use Domino's services programmatically to do things like run experiments and look at model performance results from experiments you've run, and read logs of your models when they're in production to help you debug them, and submit models for validation and review and approval in your governance process, and sort of everything throughout the life cycle. And I'm going to show you a glimpse of what this looks like. I'm going to show you 3 video vignettes that represent different stages of the life cycle here. As a little bit of a preface, we've edited these videos just to take out some of the time when the coding assistant is thinking. So we've sort of accelerated them. But these examples were not cherry picked. Like we didn't do multiple takes. This is basically how it worked out of the box, and it's really amazing. Little bit of setup just so you know what you're going to see. The way this works is in your Domino project, you write a little file that just tells the assistant where to find your core project backend in our server. So you sort of tell it the project identifier. And with that one little settings file, the coding assistants know how to go interface with our backend APIs and execute all this work on your behalf. So the 3 examples we're going to show you. The first one is a data prep example where we're going to ask the assistant to analyze some data we're going to use and then build a data prep script for us. The next one is more about model training and experimentation. So we're going to ask it to optimize a model. And then the third one is a debugging use case. So we've got a Gen AI, a chatbot assistant in production that we built, and it's broken, and we're going to ask it to debug it. So let's take a look at the first one. Let's play this is the data prep video. Okay, so this is that starter, that identifying file I told you about, just so the coding assistant knows where to go. Okay, so we ask it to analyze the diabetes data set. It writes a script to do the analysis. So coding assistant generated this script. It found the data file by looking at our project. Then it executes this script in the Domino server. It analyzes the results, comes back with a bunch of stuff about what it sees in the data set. Then we ask it to write a data transformation script. It writes the data transformation script to prepare it for a modeling use case, and the executions of both those scripts are tracked in our system of record, in our experiment manager, and the derived data set or the transformed data set is there as well. I know that went really fast, but basically we just used an assistant to generate a preliminary data analysis, generate a data transformation script. It did that by looking up the data in our Domino project automatically. It kept records of the executions it ran, and now it's going to generate a summary of what it did. So this could be plugged into a model validation questionnaire. This could be plugged into a summary of your project, or handed off to your colleague. As a segue to the next step, now we asked it to generate a model training skeleton if we wanted to try to use a neural net approach to train a predictive model based on this data set. Okay, so that was data prep. It's pretty cool, right? It's cool. Okay, it gets cooler, hang on. So now, at the end of this video, we had to generate a scaffolding file for a model training script we wanted to run. The next one, we're going to assume we built our own model scaffolding. We're not going to use the one that was auto-generated, though you could. But let's say we've inherited a project. We've got someone else's model training scaffolding file. Let's go to the next video. So this is someone else's model training script. It's a scaffolding for doing a neural net. We're going to ask the assistant to understand the training code, the model framework. So it's going to read the contents of this file. Now we're going to ask it to optimize a model with different parameters using this framework we inherited. So it's going to do an initial set of parameters, learning rate, depth of the neural network, et cetera. It's going to run an experiment through the Domino API. It looks at the results automatically, sees it's got an accuracy of 97%, something like that. Here's the record of what it did. So that was all automatically preserved. The output, the metrics, the experiment parameters are all tracked automatically. Now the assistant looks at that result and says, I think we can do better. It's going to run a new version of the training script with different parameters. It updated I didn't see which one it updated. Okay, so now it improved its accuracy. Now it got up to 97%. But now it's a little worried about overfitting. Now it thinks maybe the accuracy is too high. It increases the dropout rate. It runs another iteration of the experiment. And then it summarizes what it did across 3 or 4 different experiment runs with its final accuracy. Again, all those experiments and all those results are tracked. They're immutably preserved. There's a history of what the assistant did, so it's not lost to the winds of time. And it can summarize exactly what it did, not just what the final model is, but it can summarize each step along the way and why it tried what it tried. So again, it could be plugged into a governance questionnaire, or could be handed off to a colleague or documented for preservation of knowledge in the organization. That's pretty cool, right? Okay, here's the final example I want to show. The use case here, oh, sorry, you don't play, pause it for 1 sec. Okay. Oh, wait, sorry, hang on. Go back, let me introduce it. Go back. Okay, so the use case here is, well, false transition. We've built a chatbot assistant for analyzing financial regulations. And in the scenario here, that chatbot has broken. We got an alert saying one of the queries a user put in caused it to error. And we don't know why. And so what we're going to do with our integrated Domino-backed development environment is we're going to ask the AI assistant to help us debug and fix that running production chatbot. And the chatbot is built with a pretty standard RAG architecture. So it's an LLM backend. It's ingesting a bunch of documents that reflect the regulations. So it has the latest information about how to respond to questions. Okay, so now let's look at the video here. Okay, so we've got the project open. This is the code that was running. We tell it to look at the logs because there's an error message in the logs. So it knows what app has been deployed associated with this project. It finds this regulatory intelligence app. It looks at the logs. It sees one of the responses that wasn't good was response number 3. So we say, hey, look at response number 3. What do you think's happening? It looks at response number 3. It identifies that the retrieval system looked for a document but couldn't find information about this crypto question. It looks at the logs associated with the data ingestion task, and it finds the error. And it finds that the error was trying to ingest a Word document format instead of a PDF. So it knows, hey, there's a bug in our data ingestion pipeline where we don't know how to handle Word docs. We ask it to help us fix the issue. It creates a new Domino-backed development environment. It ingests all our files and all our training data. It spins up the command to let us connect to it from our own local development environment. It pulls that up. It takes us to the spot in the code where we handle this ingestion. We ask it to fix it. So it adds the code to help process Word documents instead of just PDFs. And it makes the change, and it shows us the diffs before the human can decide whether we want to commit this back to Git. What do you guys think? Thank you. All right. We think this is going to be the future of how data scientists are going to work. We're really excited about it. The point I really want to underscore, these videos we've showed, I think of them as the tip of the iceberg that's above the surface. I think they're pretty cool. if you just look at them on their own, they look a little bit magical. But what's powering all that is the rest of the iceberg that's underneath the surface of the water. These kinds of demos, these kinds of ways of working, they're only possible when you have this strong foundational platform that's able to do all these underlying capabilities in an automated way, in a programmatic way, in a safe way. So the ability to access and orchestrate all this different infrastructure you need, whatever tools you want to use, whatever IDEs you want to use, whatever data sources you want to use, to deploy models as APIs, to deploy models as apps, and at the same time, to have that all be done in a way that is automatically keeping immutable records of all the work you do. What's the history of experiments you try? What's the data you use? What was the reasoning for why you did certain things? The power of having all of that done automatically for you, while at the same time giving your data scientists the flexibility to use their preferred tools, that is what's unlocking, in our view, the ability to scale up an AI factory, unleash data science productivity, and to push more and more of these AI systems and models into production with both speed and safety. And that's where we see the future of the space going. We're really, really excited about what you all are going to be able to build with the new features we've got in our recent release, but also what we're building with the Vibe modeling, next generation of tooling for data scientists. So thanks very much, and looking forward to talking to all of you at the rest of the event.